Section 5.4, Systems of Nonlinear Equations in Two Variables. So I want students to realize what this is actually stating. So we have a system, so two or more equations, but now we're not going to be linear anymore. We're going to be nonlinear. So we could be a circle, we could be a parabola, all kinds of things. But again, we're still going to be in just two variables. So the things that I need you to know how to graph are still lines. I also need you to know how to graph parabolas. And I need you to know how to graph circles. So those are the three things we're going to be graphing in the systems of nonlinear equations. So we did system with two variables, and then we did system of three variables. And with three variables, you saw that we still had the same possibilities of solutions. One solution, no solution, or infinitely many. But with systems of nonlinear equations, we would have all kinds of different possibilities. For example, if we had a parabola and a line, we could have no solution. If we had a parabola and a line, we could have one solution. Or we could have two solutions. With a circle, we could have one, we could have two, we could have three, we could have none. I didn't show that one, but you could have no solution. You could have four solutions. So the problem is with this is you're not really sure how many you're actually searching for. So you need to make sure you find all of the solutions. For this one, there would be no solution with a circle and a line. You could have one solution, you could have two solutions. Now we're not going to graph ellipses, but if you had an ellipse in a circle, you could have no solution. 1, 2, 3, 4. So there's all kinds of possibilities. So how do we know how many solutions we should find? Well, you need to make sure that it's going to satisfy all of the equations. It should still satisfy all of the equations. So I will give you some hints on when, not really how many you should be looking for, but how do you know which ones you should plug it back into and the checking part. So we'll have more possibilities for solutions than which is systems of linear equations. So let's go and do number one. We still have the same, we still have the same strategies, which is either substitution or the addition method to eliminate a variable. Just so you know, as long as x has a power 1, or if they're both x squared, you can do the addition method. So like I could eliminate the x's, but I could not eliminate the y's because one has a power 1 and this y has a power of 2. So be careful if you're going to try and do the addition method. You want to make sure they have the same variable races, because I know x is going to equal 2y. So I'm just going to plug 2y in wherever I see x. So I get 3 parentheses, 2y minus y squared equals 0. So we end up with 6y minus y squared equals 0. Now with that, you see it's quadratic, and with quadratic we need to make it equal to 0 so we can try and factor and solve. So what can I take out? I can take out a y because this is just GCF. So 6 minus y equals 0. And so y is going to equal 0, or y would equal 6. Now, we know that it looks like it's going to intersect in two spots, but maybe more. So which one should we plug it back into? In the previous sections, it didn't matter if we plugged it into the first or the second equation because it should satisfy both. But with nonlinear equations, you should plug it back into the one that's a line, if you have a line. If you don't have a line, you should plug it into the parabola. If you don't have a parabola, you should plug it into the one that creates a circle. So what I tell my students is plug it back into the one that has the least amount of powers bigger than 1. So if you have a line, plug it back into the line and you don't have to worry about extraneous solutions. If you don't want to think about which one you should plug it into and just plug it back in, make sure you always check to make sure it satisfies all of the equations. So because this is a line and this is a parabola, I know I should plug it back into my line instead. So I'm going to find what x is when y is 0. So I end up with x being 0. So one place that it intersects is 0, 0. Then I'll find out what x is when y is 6. So I'm going to get x equaling 2 times 6. So x would equal 12. So my other intersection point would be 12, 6. So I definitely know it satisfies the second equation. So plug in a 0 and a 0, and I do get a 0 there. Plug in a 12 and a 6, so that's 36 minus 6 squared, which is 36, so it does equal 0. So if you decide which one you should plug it into by looking at the powers, you should be able to check your answers and they should work. If you don't kind of determine which one you should plug it into, Make sure you plug it into both and check, and you might get some extraneous solutions. So again, plug it into a line if you have a line, plug it into the parabola if you don't have lines, and then if you don't have either of those, then it's just going to be circles. Alright, so I'm going to skip number 2 for now. Let's go on to number 3. Number 3 has y equaling 4 minus x squared and y equaling x squared minus 4. Again, this is already set up for me in substitution, so I'm going to put the 4 minus x squared in for y. So 4 minus x squared equals x squared. Careful that you saw this correctly. The x squareds do not cancel. If I add over the x squared, I get 2x squared. If I add over the 4, I get 8. Divide by 2, so x squared equals 4. So x is going to equal plus or minus 2. So right now in one of my ordered pairs, it's going to be 2 comma something. And in the other one, it's going to be negative 2 comma something. So I need to figure out what the y values would be. Now, which one should I plug it back into? Well, this is a parabola, and this is a parabola. So you should be able to plug it into either one. So I'm just going to plug it into the first one. So y is going to equal 4 minus 2 squared. 2 squared is 4. So 4 minus 4 is 0. Negative 2, plugging in negative 2 into there, I get y equaling 4 minus negative 2 squared. That would be positive 4 still, and 4 minus 4 is 0. So it looks like it intersected, these parabolas intersected at 2 spots. So again, let's check here, put a 0 here and a 2 here, and you definitely does check out. Put a 0 here and a negative 2 here, and again, negative 2 squared is positive 4, so they both check out. So those would have 2 intersection points. Now, on number 4, we have x squared equaling y minus 1 and 4x minus y equaling negative 1. I probably would do substitution by adding over the 1 and substituting in, or solving this one for y and substituting in. You cannot eliminate the x's because of the different powers. If you want to subtract over the y, then you could do addition method there. I'm going to go ahead and give you the answers, so I want you to try number 4. We have 0, 1, and 4, 17. So go ahead and try number 4 later on and see if you get those answers. Alright, so let's look at number 5. We have x plus y squared equals 4 and x squared plus y squared equals 16. I'm going to go ahead and do the addition method. I've done substitution method a couple times. The addition method says, okay, well, we cannot eliminate the x's because they're different powers, but we could eliminate the y. So I'm just going to multiply the first equation by negative 1 because that would eliminate my y squareds. So I end up with a negative x, a minus y squared equals negative 4. And I'm going to add that to the second equation, which is x squared plus y squared equals 16. I'm going to add those together. Well, those are not like terms, so just put them side by side. X squared minus x. The y squareds do cancel, and 16 minus 4 is 12. Now, looking at that, we know it's quadratic, and if it's quadratic, we need to make it equal to 0 so we can factor and solve. So I'm going to subtract over the 12, and then I'll get into my factoring. So factors of negative 12, that up to negative 1, would be negative 4 and positive 3. So my x values would be 4 and negative 3. So again, it looks like they intersect at 2 spots. When x is 4 and when x is negative 3. Now, parabola, and this is going to be a circle. So again, plug it into the one with the least amount of powers bigger than 1. So I want to plug it into the first equation, not the second. If you plug it into the second, you might just get some extraneous solutions when you check it into the first. So again, try and plug it into a line if you only have powers of 1, or into a parabola if you only have 1 squared. And we only have a y squared, so we can plug it into the first one and not have to worry about extraneous solutions. So x is 4, so 4 plus y squared equals 4. That's going to give me y squared equaling 0. Take the square root of both sides, not forgetting plus or minus. But again, 0 doesn't have a sign, so we just get 4 comma 0. Plug in the negative 3. Now be careful here. It's negative 3 squared plus y squared equals 16. Negative 3 squared is 9. 9 plus y squared equals 16. So that says y squared is going to equal 7. And then I take the square root of both sides. So y is going to be plus or minus the square root of 7. So this time we have that a parabola and a circle intersect at 3 spots. 4, 0, negative 3 square root of 7, and negative 3 minus the square root of 7. Now, don't shy away from checking this in the other equation. When you plug in a 4 and a 0, that's going to give you 16, and it works out. When you plug in a -3 squared is 9. When you plug in the square root of 7 and you square it, the square and the square root just cancel. So 9 plus 7 equals 16. Same thing when you plug in a negative square root of 7, but you square it, you're just going to get a 7. So 9 plus 7 is 16. So they do both check out. So don't shy away from checking square roots, because when you plug it in, they're just going to cancel. All right, so on number 6, let's go ahead and do addition method. We could eliminate the x squareds if we wanted to, but it's a little bit easier to eliminate the y squareds. All we need to do is multiply by a -1. So the first equation is going to stay the same. The second equation gets multiplied by negative. So that means all my signs change. And the reason why I do that is because I can see that the y squareds will cancel out. So we have a 4x squared minus x squared. Those are like terms. So that gives me a 3x squared. The y squareds cancel, and 13 minus 10 is 3. Divide by 3 first. You can't take the square root yet. Divide by 3, so you get x squared equaling 1. So taking the square root of both sides, we get plus or minus 1. So right now, my ordered pairs are going to be 1 comma something and -1 comma something. So where should I plug it back into? So looking at this equation, this would be a circle. Well, actually it would be an ellipse because they're not the same, but again, I'm not going to ask you to graph those. And this would be a circle. Well, looking at your powers, everything has a square, so it doesn't matter which one you plug it into. I'll just plug it into the second one. So x is 1, so 1 squared plus y squared equals 10. So y squareds are going to equal 9, so y is going to equal plus or minus 3. So there's 2 intersection points there, one positive 3 and one negative 3. Now let's plug in a -1. So we get -1 squared plus y squared equals 10. Again, y squared equals 9. Take the square root of both sides, not forgetting plus or minus. So I do get plus or minus 3. So my ellipse and my circle intersected 4 times. So it would have been something like that. Again, don't worry about the graphing part of it, but I do want you to have some visualization of it. So far we had ones that intersected twice, intersected 3 times, intersected 4 times, but we also could get a no solution, or possible 1 solution. So those I haven't shown yet. But let's look at number 2. Again, try number 4, make sure you can do number 4. Number 2 has negative. You could do substitution, or you could do the addition method. I kind of like the addition method, so all I'm going to do is multiply the first equation by -1, because that would eliminate my y's when I add them together. So I get a positive x plus y. Let me start over. Distributing my negative, I would end up with a positive x minus y equaling -4, and I need to add that to x squared plus y equaling 3. So when I add those together, again, x squared and x are not like terms, so x squared plus x, the y's cancel, and -4 plus 3 is -1. So then I'm going to add over the 1, so x squared plus x plus 1 equals 0. The bad thing is this is not factorable, so I'm going to have to use a quadratic formula. So x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this one was kind of nice because everything was a 1, but I am using the quadratic formula. So x is going to equal -1 plus or minus the square root of, look what happens in here. We get 4 times 1, which is 4, and we get 1 minus 4, which is -3 all over 2. With the negative under the radical, we know that means they're not real, they're imaginary. So what happens here is there's no solution, no real solution, because you're not going to get a real x value. So what does that actually mean? That means these never intersected. So if I graph the line and I graph the parabola, I would see they would definitely not intersect. So if you can, take the time to graph these on some coordinate plane, and you will see that the line and the parabola do not intersect. To be able to graph the parabola, I would probably subtract over the x squared, and we know what transformations does. The negative flips it over the x-axis and then moves it up 3. And you'll see that they don't intersect, and that's why there's no real solution. So the last one is sort of a word problem, but not really. Again, if I give this to you on the test, I will not accept guessing. I try and keep the numbers a little bit small so you don't have to work with really large numbers, but that means some of y'all like to try and just guess the answer, and that's not what I'm looking for. I'm looking for you to understand how to set up equations and solve equations. So first thing, the sum of two numbers is 20. So x plus y is 20. The product is 96. Product means to multiply. So x times y equals 96. Now here's the problem. On all the problems that we had above, we had plus signs and minus signs in between every term. And that's true in the first term, but not in the second term. So we cannot do the addition method. We either have to do substitution or that's it. So we're going to either substitute for x or substitute for y. I most likely would like to get x by itself or y by itself in the first equation, because if I try and get x or y by itself in the second equation, I end up with fractions. You can go that route, just be a little bit more challenging because of the fractions. So in the first equation, I'm just going to get x by itself, so I get 20 minus y. So I'm going to plug 20 minus y straight in for x. So this becomes 20 minus y times y equals 96. So because we have parentheses, probably the next thing to do is distribute. So I get 20y minus y squared equals 96. Because it's quadratic, we know we need to make it equal to 0. Because my y squared is negative, I'll probably add over the y squared and subtract over the 20y. So we get a positive plus 96. Then we have to factor. Factors of 96 add up to negative 20 would be negative 12 and 8. So we factor this into y minus 12. We're going to set each one equal to 0. So y would equal 12 or y would equal 8. Now, it did say find the numbers. So when we plug in a 12 back in for y, we get x equaling 8. Plug an 8 back in for y, we get x equaling 12. So the numbers are just 12 and 8. So the numbers are 12 and 8. So that's it for 5.4. Again, we can still use the addition method or the substitution method, but be careful if you're going to do the addition method. If you're going to eliminate a variable, you got to make sure that variable has. So